Okay. So yesterday we were discussing about the GPS system, that is global positioning system. So this system is based on satellite, and it is used generally for navigation. Okay, and finding position and location. So the important point is that this navigation, positioning, and timing synchronization, everything occurs in real time. Okay, and nowadays this type of system has become important part of most of the applications. So all of you are using such applications, so you know it. Okay. Now, generally, GPS consists of 24 satellites. So you remember this. It consists of 24 satellites. 24 satellites are used for this application, and these satellites are called as MEO satellites. MEO. That means medium Earth orbit satellite. So there are three types of orbits: low LEO, that is low Earth orbit, and HEO, that is higher Earth orbit. It depends on the distance from the sea level. Particularly this MEO satellite orbit, they revolve from 2000 kilometer to 35,000 kilometer above sea level. Now, uh, arrangement of this satellite is called as constellation. Okay, so such a constellation of satellites is used for GPS application. Okay, so two groups are made, and approximately each satellite equal to 12 hours. So total of 24 hours. Each group of 12 hours. And these two adjacent constellations, generally they are separated by 60 degrees in longitude. So these are some of the important points that you have to remember. Okay. So generally for application, at a time, out of these 24 satellites, 4 satellites are used at a time to navigate or to find the location. So this also needs to be remembered. Okay. So now, as we have seen, there are mainly three parts of this system. The space segment, the control segment, which is also called as ground segment or ground stations, user segment, or GPS receiver that we are using. Okay, so these are the three components. Now, coming to the space segment of GPS system, space segments, it consists of basically 24 active satellites. Okay, and these satellites are assembled with huge solar panels with rechargeable batteries. Okay, so these solar panels are used to continuously power these satellites. Now, what is the function of satellite in the space? Okay, you have already studied the working principle of ultrasonic sensor. Okay, so the same principle is used here, and satellites in the space, they generally they send radio signals, and these radio signals are received back from the earth stations, and these are used for finding time accurately, and with help of this time, the location, a particular location is identified. Okay, so messages are retransmitted to the station which is on the earth, and this message consists of information about the location of user or where that particular receiver is situated. Okay, so this is the way in which it works. So space segment consists of satellites. Now going to the next segment of the GPS system, it is called as control segment. And control segment, generally it is also called as ground station, which is present on the earth. And this ground station consists of control unit. And this control unit is made up of several monitoring and control stations and a number of antennas. Okay, so the monitor stations generally monitor GPS satellite signal. Okay, and these signals are then sent to the master control station. Okay, and after receiving the signals from satellite, this master control station, uh, it will check the specifications, and it will perform certain operations on it. And after revision of those output of those operations, revised signal is sent back to the GPS satellite. Okay, and they are sent back through, as you can see, by ground antennas. So global positioning system control segment generally consists of control units and control stations. Okay, there is one master control there, and functioning of this particular segment is to receive the signal from satellites, take that information, process that information, and after processing the information, again the signal is sent back with help of ground antennas to the satellite. Now the third segment, or you can say third component of your GPS system is user segment. User segment is nothing but your GPS receiver that you are using for navigation. Okay, so it may be present in your mobile phone, laptop, PC, or a separate GPS receiver might be there. Okay, so these devices, they receive the signals from this GPS system and determine how far away that particular location is from each satellite. Okay, so the satellite are used to find the location in this way. Okay, so how location can be found, or how the GPS system works? Obviously, all the three elements of GPS system, they work in synchronization, and this results in accurate and reliable output of uh, position or location of the receiver. Okay, so basically this GPS positioning is based on what is called as trilateral principle. So in trilateral principle, three satellites are involved. So at a time, three satellites are involved, and this determine the position by measuring the distance of your GPS receiver to that particular satellite, and coordinates of that satellite are already known, but location of receiver is not known, and that is found by finding the distance between given satellite and receiver location. Okay, so this finding distance is called as trilateration. Okay, so apart from trilateration, there is one more operation which is called as pseudo ranging. Okay, and this pseudo ranging is performed with help of four satellites. So trilateral operation is performed with help of three satellites. So out of 24, only 4 satellites are used by one user. Okay, to determine the position of the receiver. So, two operations are performed as you can see here, and these two operations are positioning of the receiver using trilateration principle and pseudo range calculation. So, pseudo range calculation and trilateration principle. So, these two steps are used in order to find the location. Now, here, as you can observe, the first operation is performed by using trilateration principle. Okay, so in this, two-dimensional position is calculated. Two-dimensional position means latitude and longitude of a particular point of interest is found. Okay, so initially, a single satellite is used to track the location of the point of interest. Okay, the calculations are made. Now, this location information again is spread over a large area, and data from a second satellite is also calculated, and that is added to the first data. Okay, so initially the information was spread over a large area. Now this second calculation will lead to narrowing of that area. Okay, so this will be the point where the two areas of the satellite overlap. Okay, somewhere here, as you can observe. So a large area is now divided into smaller portion of area. Okay, so the system identifies that the current location is somewhere here in this area. Okay, now what is done? The third satellite is used. Okay, and when the third satellite is used, as you can see, the range of this satellite will intersect the range of earlier two satellites, and this will provide the accurate position, because this is the intersecting point of all the three circles, and this gives rise to a single point. Earlier it gave a whole area, then it provided this intersection area, and now with help of third satellite it is providing exact position of the receiver. Okay, so this is what is called as trilateral principle, and here the simple equation for distance is used, because all of you know speed, formula for speed is equal to distance divided by time. Okay, and as satellites are transmitting radio waves, and time required to travel those radio waves, that is known. Okay, so as I told you, satellites, they transmit the signal to the ground station, and ground station send back signal to satellite. Okay, and with help of these two, the receiver is going to work. It is going to transmit and receive the signal, and transmission and reception of the signal can be calculated. Time required to transmit and receive the signal is calculated with the system. So once you know the travel time, you can find the distance between the satellite and the point of interest. Okay, and that can be found by the simple formula: distance is equal to time required to travel the distance multiplied by speed of light, because all radio waves, they travel with the speed of light, and all of you know what is speed of light. Okay, so it is some constant value which is known. So travel time is known, speed of light is known, and distance can be calculated, distance of the satellite from point of interest. Okay, so this distance is used to find the coordinates of the point of interest. So already coordinates of satellite, they are known. So from the information of the coordinate of satellites, the coordinate of point of interest uh, is calculated. Okay, so here fourth satellite is used to reconfirm the position of the point of interest. Okay, so three satellites will find the actual position of point of interest, and fourth satellite is used to confirm whether the position is correct or not. So in this way, four satellites are used, and the receiver will determine three-dimensional position of the point of interest. So what are these three dimensions? Latitude, longitude, and altitude. So all these three dimensions are um, calculated or determined by the GPS system. Okay, and these calculations are very precise calculations. And as number of satellites are involved here, and atomic clocks are used on satellites, which are very, very accurate, the precision and accuracy of measurement of this time, it increases. Okay, so the number of satellites, use of atomic clock, this will increase accuracy and precision in measurement of the location in this particular type of system. Now the second process, which is called as a pseudo range calculation. Okay, now, pseudo means it is false, as you know it. We have studied in spread spectrum technique. Pseudo random codes are used for transmission, okay, or reception. So it is a kind of modulation technique where the signal added with a sequence of digital codes. Okay, so that is what we have studied. So this type of technique is used in GPS satellite system. Once the location is found out, what is done is pseudo range calculation is done. Okay, and this pseudo range calculation is done on two frequencies. One is called as L1 and another is called as L2. Okay, so the primary signal to be broadcasted is broadcasted on frequency L1, and this is modulated with the two types of information signal. One type of information signal is called as coarse and acquisition code. So this is rough estimation, and P or precise code, so which is precise code or precise calculation. So these two information signal, they will undergo spread spectrum modulation. Okay, and how this spread spectrum modulation is carried out? The carrier signal, which is specified by L1, is repeatedly inverted with 180-degree phase shift. That means phase shift keying type of modulation is used, and uh, what is done after PSK, the codes are impressed over this carrier signal. Okay, the replica of the precise code, actually it is broadcast on the second frequency. Okay, precise code is broadcasted on the second frequency. This second frequency is called as L2 frequency. Okay, so here what is done, in addition to this specific phase change, which is of 180 degrees in the carrier, to this pattern, additional data is added. And this additional data will consist of navigation message. Okay, so navigation message means it will give information about the coordinates of the location, and this is added to the phase shift keyed signal, and to again this the digital codes are attached, and to attach this digital code, the signal generator consists of 10-bit shift register, and this 10-bit shift register is going to generate a coarse acquisition code pattern, and this code pattern is generated with the help of exclusive OR gate. So generally, PN codes, that is pseudo noise type of codes, are generated with help of exclusive OR gate. Okay, so this will occur as noise to all other communication system except for the system which is of our intention. Okay, so the resulting digital output that we are getting out of such a system is called as a, pseudo random number or PRN. Okay, so now this PRN sequence will be transmitted in the pseudo range calculation. Okay, so here your receiver is going to receive this spread spectrum signal. Okay, so transmitter has certain sequence of codes, and the same sequence of codes must be known by this receiver. Okay, your receiver must have the same type of code as that of transmitter. So for this, receiver will search the different sequences, and one sequence will match with a particular pattern. Okay, and this is achieved by a mathematical operation which is called as correlation. So when two things are exactly equal, it will produce high output by identifying a particular sequence of the transmitter. So once the signals are matched, once the signals are matched, with help of that signal, the computations are performed to find the distance of point of interest to each satellite. Okay, so frames which are transmitted by satellite, they are called as pseudo range frames, and with help of these pseudo range frames, the calculations are carried out, and with help of these calculations, the distance is found. And once distance is found, the coordinates of that point of interest is calculated with the help of known coordinates of the satellite. Okay, so this is what is actually done here. Now, the time that the signal transmitted from satellite is recorded by atomic clocks on the satellite, and the time of the signal reception is recorded by the receiver's clock. Okay, so two clocks are involved here. One clock which is present on the satellite, which is atomic clock, and another clock which is present in the receiver. Okay, so difference between these two time frames is called as pseudo range, and this is measured using units of time like a second, minute, etc. So by calculation of this timing, the distance can be calculated, as you can see. Okay, now let us go to the block diagram of GPS receiver. So actually, what your GPS receiver consists of, that you can observe here, it is just like any communication system. If you compare the components of communication system with that of GPS receiver, they will match. Okay, so it will have receiving antenna, it will have amplifier. There is one frequency converter which is called as down converter, and then there is IF amplifier. After that, it is converted into digital with the help of analog to digital converter, and this digital signal is applied to digital signal processor and microprocessor. So here computations are done, and result of the computations will be displayed on the display provided in your receiver. Okay, so the function of the receiving antenna is to receive the satellite signal. Okay, the antennas which are used in GPS system, they are circularly polarized antennas. Means their electrical polarization is in circular fashion. So such type of antennas are called as circularly polarized antennas, and they are used for receiving. Okay, and the amplifier which is used here to amplify the signal which is received from antenna are called as low noise amplifier. They are going to amplify the received weak signal, and they will also cancel the noise. So noise content is reduced to very greater value. Okay. So after this, the received signal has certain frequency, and that need to be converted into a frequency of your receiver. So this is done by computing the difference between the frequency, and a single frequency is formed, and which is called as intermediate frequency. Meaning of IF is a intermediate frequency. So certain standard intermediate frequency is decided for the receiver, and received frequency is converted down to the intermediate frequency. So this is done by a circuit which is called as a down converter. Now, this IF frequency is again further amplified with the help of amplifier. And this amplified signal is now converted into uh, digital with help of analog to digital, which is present in the receiver. So it will follow sampling and quantization and encoding processes. And in this way, it is going to convert the analog signal into digital value. So this digital signal is then fed to digital signal processor, and this digital signal processor, it is going to generate the CA code. Okay, so this will generate the actual CA code, DSP signal processor. So it will find the desired information or desired code from a given signal. Okay, so for that it has to perform number of operations, just like correlation operation. Okay, so particularly correlation operation is used to find the CA code. Now, after this, once CA code is found, this CA code will be applied to the microprocessor, which is present in the receiver. And the microprocessor will perform the calculations by using algorithm or program which is stored in the microprocessor. And with help of these calculations, position and position of a particular point of interest is found. Okay, so uh, uh, other timing signals and control signals, other timing signals and control signals to operate a whole receiver, they are also provided by this microprocessor. Okay, now after processing, uh, position of a point of interest is found, and this position will be displayed with help of the display unit which is present in your receiver. So the three-dimensional information, altitude, longitude, and latitude. So all this information will be displayed on the screen. Okay. So this is how your GPS receiver will work. Now, you must know the applications of global positioning system. So initially it was designed for military, but today it is widely used for civilian application. Okay, so location finding, that is determining a position. Navigation means moving from one location to another location and determining the position. Uh, tracking or monitoring of the object, that can be done with help of GPS. Creating of maps, this can also be done with the help of GPS. Okay, and it provides the precise timing, precise calculated timings will be provided by this type of system. Okay, now let us go to the next point of this. You should know what IRNSS is. IRNSS is Indian Regional Navigation Satellite System. Okay, so this is an independent developed satellite navigation system by India, and this is established and controlled by the Indian Space Research Organization, that is ISRO. Okay, so if you observe the architecture of this IRNSS, it will contain the same three segments. space segment, ground segment, and user segment. Okay. So if you go to the specification of these IRNS, then here you can see that uh, satellite constellation, it will consist of geostationary orbit satellites. So our Indian system uses geostationary satellite orbits. Okay. And the ground segment, it consists of navigation center by ISRO, spacecraft control facility, range and integrity monitoring system, network timing centers, and CDMA ranging stations. They are also there. Laser ranging stations are there, and data communication network is there. That is what is present in the ground segment of our Indian satellite segment system. Okay. Now, the user segment mainly will use the two frequencies, L5 or S band frequencies are basically used. Okay, so dual frequency uh, are used for this communication, as you have seen while we have discussed the working of the GPS system. Okay, so this is what is about our Indian system. So this completes our uh, chapter number 2 of paper number 2,